Hello everyone, myself Sanjeevani Surendra Chaudhary. Today's my seminar topic is Bragg's method of X-ray diffraction and Deby Sherrer method. In this method we will discussing about X-ray diffraction, Bragg's law, Bragg's equation, application of Bragg's law, Deby Sherrer method and application of X-ray diffraction. Then X-ray. So what is the X-ray? X-ray is a short wavelength electromagnetic radiation which is used to produce the electron from the inner shell orbital. Consider these are the orbitals. The X-ray is incident on the inner shell orbital and reject the electron from the inner shell orbital. Then there are the penetration power of X-ray. There are two types, hard X-ray and soft X-ray. The hard X-ray which have the high frequency and have the more energy, and soft X-ray which have the less penetration power and have the low energy. Then the diffraction. Diffraction is a wave phenomena in which the apparent bending and spreading of the wave when they meet to an obstacle. Means this is a surface. When the X-ray is incident on it, it is not transmitted through it, it is diffracted from the surface. It is called as diffraction. Then X-ray diffraction. It is a technique used to determine the atomic and molecular structure of a crystal in which the crystalline atoms cause a beam of incident X-ray to diffract into the many specific direction. And the atomic plane of a crystal cause an incident beam of X-ray to interfere with one another as they leave the crystal. The phenomena is called as X-ray diffraction. Means this is the crystal. When the X-ray is incident on it, it is transmitted to the various direction, but it is not transmitted to it. And this technique is used to determine the atomic and molecular structure of a crystal. Then Bragg's law. Bragg's law gives the angle of coherent and incoherent scattering from a crystal lattice. When the X-ray are incident on an atom, they make the electronic cloud move as does any electromagnetic wave. The movement of these charges re-radiate wave with the frequency is known as relay scattering. First of all, what is a relay scattering? Relay scattering which have the same frequency of incident light and reflected light. Consider these are the sample. When the incident light incident on it, it is transmitted through it, but no energy is exchanged between the any other atoms or molecule. Means the amount of energy is incident on the atom, and that amount of energy is reflected from it. There are no exchange of energy takes place. Then the Bragg's law. In the Bragg's law, various apparatus is used: X-ray tube, filter, colorimeter, crystal and detector. The X-ray are incident on the crystal from the X-ray tube, which is transmitted through the filter and colorimeters. Then it is a diffracted ray is detected by the detector. Then a similar process occurs upon the scattering neutron wave from the nuclei. This re-emitted wave field interfere with each other either constructively or destructively, producing a diffraction pattern on a detector or film. The resulting wave interfere pattern is the basis of diffraction analysis. The analysis is called as Bragg diffraction. Then there are two layers of the crystal which is denoted by alpha and beta, and the two wave A and B which is incident on the two different layer of a crystal which is diffracted into the C and D. Then there is put a perpendicular on it, and the distance between two layer is denoted by D. There are two angle is present, XOY and ZOY. So let's consider AO is equal to BX and CO is equal to DZ. There are part difference between them. It is equal to XY plus YZ. The part difference is defined as the integral multiple of wavelength it is denoted by n lambda. So part difference is equal to n lambda is equal to XY plus YZ. So there are the angle is present between the incident light and surface. It is called as glancing angle, which is denoted by sin theta is equal to L upon H. Now consider a two triangle. Delta is equal to XOY. So sin theta is equal to length of the perpendicular upon hypotenuse. So sin theta is equal to xy. Xy is the length of the perpendicular and oy is the hypotenuse. So rearrange it. Xy is equal to oy into sin theta. So value of oy is equal to d and it is given by d sin theta. So in second triangle ZOY, sin theta is equal to ZY upon OY. So ZY is equal to OY into sin theta and it is given by d sin theta. So put this two value in the equation number 3. So we get n lambda is equal to d sin theta upon d sin theta is equal to n lambda upon 2d sin theta. This is the equation of Bragg's law. So where n is equal to order of diffraction. The order of diffraction is 2 because the 2 layers of crystal is used, and lambda is equal to wavelength of X-ray, d is the interplanar distance, theta is equal to glancing angle, and sin theta is equal to 0, 30, 45, 60 and 90. These are the angles. So sin 0 is equal to 0, sin 30 is equal to 1 by 2, sin 45 is equal to 1 upon root 2, sin 60 is equal to root 3 by 2 and sin 90 is equal to 1. Then application of Bragg's law. Bragg's law is used for the various purposes. For solving the Bragg's equation gives the dispacing between the crystal lattice planes of an atoms that produce the constructive interference. A given unknown crystal is expected to have many rational planes of an atom in its structure. In the X-ray diffraction, the inner planar spacing of a crystal is used for the identification and characterization purpose. The computer tomography use many X-ray slices at different angle for the scan the image image inside the body with the help of Bragg's law. Then the ultrasound use echo from the sound wave used to locate the different organs inside the body and can be used to monitor the growth of unborn baby. The magnetic resonance imaging use the powerful magnet to measure the water content of the different types of the body tissue. So it is a slow process but generate incredible detailed images of the body. Then the positron emission topography detect the radioactive traces that are injected into the body. Then Deby Sherrer method. Instead of crystal, in the Deby Sherrer method, powder is used instead of the crystal. So this method is useful for the sample that are difficult to obtain in the single crystal form. A very small amount of powder material is sealed into the fine capillary tube made from the glass that does not diffract X-ray. The specimen is placed in the Deby Sherrer camera and it is accurately aligned to be on the center of the camera. The X-ray enter into the camera through a collimator. The powder diffract the X-ray in accordance with the Bragg's law to produce the cones of the different diffracted beams. This is the camera and there is the capillary in which the material is present, and this is incident light and it is diffracted light which form a cones of the diffracted light. Then second is the application of X-ray diffraction. There are various applications of X-ray diffraction. First is the differentiation between crystalline and amorphous material, then determination of the structure of a crystalline material, determination of electron distribution within the atoms and throughout the unit cell, determination of orientation of a single crystal, determination of texture of a polygrain material, and measurement of the strain and the small grain size. Thank you.